If you go to the Hubble website, you'll be able to check out the weight loads, the data sheets, cut sheets, and everything on them. As you can see, they go deep. You can get them wider, deeper, pancake drains, and they've got all sorts of different systems for different scenarios. Now, what they've got here out in Dallas is they've got some pre-poured drains that we'll be removing. They put in some metal sleeves that have eroded. The problem with having those metal sleeves and not having something of a cementitious value is the expansion-contraction rate will allow for some gapping, and you end up with a cavity around the actual sleeve of the drain. Where it erodes, it allows moisture and mold and all sorts of stuff to get stuck in between, ultimately creating a gap between where your drains will only have such a life expectancy. With these drain systems, they get poured in place and they have a chemical resistant coating on them, allowing for a much longer life expectancy, easier cleaning, less time cleaning the drains themselves. Then you can get them square. You can also purchase shovels that fit in there perfectly well. Alright, so in here we'll be removing this 7-foot section and installing new. As you can see, a ways back, about a year and a half ago, we had installed a polymer cement, or a seamless polymer floor here, a cementitious urethane, to create a nice clean work environment. What we'll be doing is, after we excavate and install the new trench drains, we'll be installing more of this polymer flooring to create a seamless floor where nothing can stay there, easier cleanup. As you can see, these are the actual installed drains that we had come by and put in on our first time around. They've got lockdown so the drain caps don't move. That's optional. From here, these drains have been eroded, so they'll allow for dips in the actual base of the drain where water can't flow. And as you can see, the walls were never chemically treated, so they erode over time. They'll be excavated about 3 inches outside of where they're at right now currently, to allow for more of a 4,000 psi or higher concrete fill to secure them into place. This is the final area. Again, it's going to be about 320 linear feet, heading to about, I think it's 2 different sump pits. We'll be taking these drains, saw cutting them today. We assume about 3 days total time down. Due to the fact that after we install our concrete, we will have to come back and put down a resinous floor, which will need time to cure out between, making sure we don't lock any moisture in. The schedule sits right now. We'll have a 4-man crew working a 12-hour shift on 3 days consecutively. Day 1, Saturday, we'll be saw cutting the perimeters of all of them with with 2 guys saw cutting, 2 guys lagging behind with some Bosch Brute hammers, jacking out the existing drains. Continue on into the next day, removing all of the drains, presetting the new drains, and begin mixing concrete and setting them. Monday, finish about midday with all of our drains, and actually allow for Monday night through into Tuesday for a good cure on the concrete itself, making sure not to lock any moisture in. From there, installing our General Polymers cementitious urethane slurry with a urethane top coat. Steve here with High Performance Systems, taking a look at our internally pitched trench drain system being installed in Dallas, Texas. About halfway through the project, which gives us a perfect chance to take a look at each different step of the installation itself and how they're laid out. As you can see, this section right here is only about a 7-foot section. Saw cut the concrete, excavated out, and you move over to here where the drains have already been set and poured concrete. We shim these pieces of wood to anchor them on a level to allow for the internal pitch to pick up and give you a good flow of water. Also coming back with our seamless floor to allow for a little bit of a slope to the drains to ensure a perfect pitch into them. Over here we finished our concrete work, leaving an edge for our seamless material to be flush with the existing floor that we had installed in the past summer. And here was a section that was finished. So as you can see, this run goes all the way to the back. From here we'll just do a light diamond grind to ensure that we remove the latents off the concrete, come back with the cementitious urethane, a polymer floor, seamless floor, and put that down on top of the concrete with a cementitious urethane top coat as well, allowing for a full chemical resistance from inside the drains to the outside, minimal downtime on cleanup, and everything pitched to their sump pit. Take a look at the progress on the other side. We just finished excavating out the concrete. Most of the areas already had an existing scupper drain system which had deteriorated, and what ends up happening is you end up with seams between the drain sections and rotting of concrete on the edges without that seamless floor, which ultimately erodes. You get lost material leaching through and so on and so forth. So as you can see from this, the drains have been set, level, balanced, and the internal section of the drain itself is pitched. I believe it's a 1/4 inch from one end to the other, a 4-foot section, allowing for water to flow and ease of installation. Over here are final sections. These drains have yet to be leveled, obviously, but with the ease of installation, it's basically a numeric sequence where you go from a high number to a low number, and they fit in like Lego pieces with a tongue and groove. From here, we'll just install 4,000 PSI or better concrete on the sides, do our keyway like on the other side. Tomorrow, hopefully, we'll have our cementitious urethane installed and top coated, and the floor will be finished.